Chinese remainder theorem questions are things like, find a number that if I divide by 11, I get remainder 3, but if I divide the same number by 7, I get remainder 4. And just to see what we're getting at here, the answer to this question is going to be 25, because it's true that 25 divided by 11 is 2 remainder 3, which is what I want. Whereas if I divide 25 by 7, I get 3 remainder 4, which was the goal. So questions like this are Chinese remainder questions, and there could be any number of equations, but for this video we're just looking at 2. So the process for solving a question like this is to first find a number. We're going to look at these two remainders, not the remainders, but the two numbers we're dividing by. And I want to find two numbers. One of them is, what would I need to multiply 7 by to get 1 mod 11? So the 7 and the 11 are the two numbers. And also, second question, it's like the same question, but the numbers are reversed. Okay. These two answers are going to be important in the process. Now, when the numbers are small enough, you can just go through the multiples of 7 until you find one that's one more than a multiple of 11. In this case, a equals 8, because 7 times 8 is 56. 56 divided by 11 is 5, remainder 1, which was the goal. There are calculator programs that answer this question for you. I gave one out in my class where we call it the modular inverse. So we would say mod inv would be the program name, and we put in 7 and 11, and out would come the number 8 as the answer. But sometimes it's small enough that you can do it. You could also, if you're watching other videos and you're from some other school, you could also answer this question by saying 7a plus 11, let's just say y equals 1, and use extended Euclidean algorithm from some other, maybe I should make this minus. And this is sort of the same question, a multiple of 7 that's one more than a multiple of 11. Anyway, that's if you've been watching videos just separate from my own classes. Anyway, 8's the answer for A, and for 11 times 2, 11 times 2 is 22, which is one more than a multiple of 7. 22 divided by 7 does give me remainder 1. So I have all the stuff I need now. I'm going to create an answer. Here's how I do it. I take the 8 from here and multiply it by the 7. Leave a little space here. And here I'm going to multiply the 2 times the 11. Now, 8 times 7 gives me remainder 1 when I divide by 11. But I don't want remainder 1, I want remainder 3. So I put the 3 here. 2 times 11 gets me remainder 1 when I divide by 7. But I don't want remainder 1, I want remainder 4. So this number, 3 times 8 times 7 plus 4 times 2 times 1, is actually 256. And if I divide 256, or if I divide this thing by 7, this term won't matter because it has a 7 in it. This term without the 4 would give me remainder 1. With the 4 will give me remainder 4, which is what I want. On the other hand, if I divide this thing by 11, then this term doesn't matter because it has an 11 in it. This 387, the 87 gets me remainder 1, with the 3 gets me remainder 3, which is exactly what I want. The only issue is that 256 is not the smallest possible number, so I'm going to subtract from this 4 times 2 times 11 a bunch of 7 times 11s. How many? 7 and 11 are these two numbers. If you do 256 divided by 77, you get 3 remainder something. Put that 3 there, and this becomes the answer. we get remainder 25 actually. So the answer is 25, and this is the representation for it, and that's how, so where the numbers come from. Again, this 3 ended up over here, this 4 ended up over here, this 7 ended up here, this 11 ended up here, running out of colors, this 8 ended up over here, and this 2 ended up over there. So those are sort of all the numbers involved. The 11 also ended up here, and the 7 also ended up over there. Anyway, it looks like a mess there, but that's the gist of how to solve a question, Chinese remainder theorem with two equations.